All right, well, we can certainly get started. People are still trickling in, but I'm sure they'll find their seats. Afternoon, everyone. I hope you guys had a good lunch. Who doesn't love pizza luce? My name is Kyle Smaagard. I'm looking forward to having a good discussion about AI and ML here. I do call it a discussion. I do like to talk about these things. So please, at any point, let me know if you have any questions. We can make this more of a discussion, especially since this has been 2 years since my last presentation, thanks COVID. Hopefully I'm not too out of practice, but I'm sure you guys will let me know. I also timed this, and this was well short of 40 minutes, so we do have plenty of extra time. And questions on the end or questions in the middle, any of that can happen. This is not a super technical talk. I'm not going to dive into coding or anything. This is definitely more of a high level, how might you implement some of these things? Mainly because, in my opinion, basic machine learning, it's really democratized nowadays. And we'll get into a little bit of some of the tools that are out there, but a single person can do a lot today. So I don't really want to dive into the, well, how can I implement some of that? More about how can I implement policies and procedures and practices that will allow me to be successful when I do want to implement that. Couple of Xkcds up there. The one on the right used to be my go-to. Unfortunately, that's really easy to do nowadays, so that comic doesn't really work anymore. But I do like it, because it does apply to a lot of things. When we're talking machine learning, it's interesting how some things can be super easy, but other things can be really hard. And it takes a discriminating eye sometimes to figure out why that might be. My opinion, there's only 2 good session slots at Minibar. This is not one of them, unfortunately. I feel like I never get one of the good ones, but I'm sure it'll be fun anyways. So who am I? A little bit of a background. I got my degree in astronautical engineering, building satellites. One of our satellites was actually launched. I went into the Air Force. I did supply chain management. While I was there and overseas, I needed something to do, so I taught myself how to code. At the time, the iPhone, Android had come out, so I said, hey, developing apps would be kind of fun. And it was fun for a while. So I did that for like 9 years. Worked for a startup out of California at one point. Did some of my own work, some of my own applications. Coded for some guy out of Ireland. So it was a lot of fun, but that's really what got me into coding. So when I got out of the military, looked for, hey, technical field seems like a good place to be. I enjoyed coding, looked for technical, found SPS Commerce, worked there for a while as a consultant, then moved into product, and then found my way, or rather they found me, Calabrio found me and said, hey, we need somebody to run this team that we put together. More on that later. And to totally round myself out, I've got a few other side hobbies. I've got a 3D printing business and then a small e-commerce startup. So none of those are really related, but just a little bit of background. All right, so what do I actually do? My title is probably the longest title I've had, Technical Program Manager for Machine Learning and Artificial Intelligence at a company called Calabrio. And I've been there for about 3 years. But what does that actually mean? Well, if you've ever called a company, called a contact center and said, hey, I'm calling my bank, or I'm calling, I don't know, well, you can't call Amazon. That's a bad example. I don't know. There's other places you can call. You'll hear the, thank you for calling so-and-so. Your call is important to us. Your call may be recorded for quality assurance purposes. Well, that's the important bit, that recording. So Calabrio doesn't actually do the recording, but we manage the software that those contact centers use to do that quality assurance purposes part. And the way they do that is by listening to them. So if you think about it, if a contact center is recording all of their calls and they want to know how well they're doing, well, they got to listen to those calls. And they're certainly not going to listen to every single one of them because they've just doubled their staff, literally. So they end up only reviewing 1% to 2%. And that 1% to 2% may or may not be important to what they're looking for. You're kind of throwing darts at a wall and hoping you find something interesting, good or bad. So that's where my team comes in, and specifically machine learning. We build features, functionality, tools that will parse through the 98% that nobody's listening to find those interesting things and point them out to people. And those interesting things can be really complex or really simple and straightforward. Think sentiment analysis. Was this positive, negative, or neutral? It's one of those simple things. Or more complex, like clustering analyses to say, hey, what's actually happening in your contact center? But that's enough about me and my background. Let's talk about what we're actually here for. Or not. There we go. Okay, not actually talking about hiring, but we are hiring. So if this kind of stuff interests you and you like data, please talk to me. We are hiring for a data engineer. All right, now we're moving on. Oh, so now it works. Okay, so AI or machine learning. People use that interchangeably. I used it interchangeably. I even threw deep learning in on the topic title, and you won't see that again throughout this talk. It's not really important, but there is a difference. So to get us all on the same page, here's how I think about it. I think of artificial intelligence as an over-encompassing field, similar to biology, right? So you have this whole big thing of artificial intelligence that has a number of smaller things in them, and one of them in particular is machine learning. You can think of that as like a tool or a technique, similar to autopsies are in biology. It's a way to answer a question or to do a thing. You do an autopsy because you want to figure out what happened. You use machine learning because you want to do something. You want to predict something, or you want to find interesting insights. So it's very similar, and those definitions I totally just stole from the internet, so they're relatively good, right? They're probably fine. Well, what does this mean for you? Well, it actually doesn't really matter, because everybody markets everything as AI, literally. But that's good for you. Why? That means everything's a green field. You can do whatever you want and call it AI. I am dead serious. I have seen companies that sell a system where you plug in your metadata and you plug in thresholds like I don't want it to be over 90 or below 80, and they call that AI. And they sell it as AI. And it's ridiculous, but it works. I have seen companies that have AI in their name and they have nothing else, but it works. So, important to know, because you could do AI without actually doing AI if you really want to. But that's not what we're here to talk about. We're here to actually talk about how you might start doing some of this stuff. So how do you start? This is an extremely high-level overview diagram, very, very detailed. But bottom line, base of the pyramid, you need data, right? You need something to be able to do something with. And you need data that's predictive. Well, what does that actually mean, right? What does it mean by needing predictive data? Well, let's take an example. The amount of vodka that I have left over in my bottle is probably predictive of how entertaining I'm going to be over the next hour, right? Now, we could guess, or we could argue all day about whether that's positive or negative correlation based on how much is left in there. But the bottom line is it's probably predictive, right? You could say if I drank more, different things would happen. If I drank less, also different things would happen. But once you have that predictive data, you have a correlation, you can say, hey, I can do something with this information that has a predictive outcome or an actionable insight that I care about. And you find those by applying those machine learning algorithms. You might look at historical data, like how much did Kyle drink yesterday, or how much did he drink at his last presentation that he did? And then we look at, well, how did people rate him? Hopefully well, not poorly. But you can build those correlations and say, well, let's feed them through some math and generate those actionable insights. Now, that is probably the easiest three-step solution you've probably ever seen, and it's definitely not that simple, right? Well, hold on, because it might actually be. I wonder how many of you are just slightly curious that there might actually be vodka in there. We can find out later. So we've got our simple three-step process, right? But how do you actually apply it? I mentioned before that is really beyond the scope of this conversation. But in my opinion, you should be asking yourself a different question. Should I be? Right? This stuff isn't free. No matter how easy it is or how straightforward it seems, there are hidden costs. There are other things you have to consider. Again, you can tell I do love Xkcd, that there are ramifications for choosing to do things that you may or may not anticipate down the line. So you need to take a hard look and say, well, are there business objectives that I care about that can be accomplished using machine learning? Speaking of that business value, this is the framework that I like to utilize when I think about value or the style of value that I'm looking for. This, by the way, is really for run-of-the-mill companies, not an AI service company. If you're a company that is literally making AI services for other companies, this does not apply to you whatsoever. This is all about, all right, well, we are maybe an e-commerce company, or maybe we build a widget, or we do lawn mowing services. Those are the kinds of companies that this is really geared towards. And I like to think of things in terms of t-shirt sizing. You've got your small, medium, and large. Developers in the room are probably familiar with t-shirt sizing, but it's basically a way to easily sort between a couple of different classes. And I threw a couple numbers down there where you can kind of place yourself in terms of the size or number of employees at your company. And then in the middle, I've got, well, what might an AI practice look like at this level? So you've got your small companies, and that's really where you're looking at, we've got one or two individuals, right? We've got our primary core business that is building a product, building a widget, or doing a service. And we've maybe hired a data scientist or machine learning engineer to build a couple of features and add to our things. At the mid-size range, you might have grown to building a team. Maybe you've got a manager, 3 engineers, a couple of data people, a couple of machine learning engineers, data scientists, et cetera. But now you're larger. You've got several teams. And then you get to the really large, Best Buy is a good example. They have multiple teams that are focused on machine learning in all different aspects that are super hyper specialized. We're not really going to focus too much on those because that is a whole nother world. And there's a lot of different implications at that level. On the right-hand side, though, you can kind of see how I think about, well, what style of things do we use at each of these levels? And again, at that first level, you're looking at those companies that are really spending 1 or 2 people on this task. So if you really want to move fast, and fast is important as we'll get to later, you really got to be using those pre-built functionalities. We're going to find libraries to apply. We're going to find already written frameworks. We're not going to be doing a lot of our own in-depth research because that takes time. And if you're going to spend 12 months in a company that's maybe 80 people building something, well, you better be really sure that you're building the right thing. Did anyone see that? Did anyone go to the MVP talk just before lunch? Yeah, I was like, I should steal this guy's slides. He's got so many things that their slides look way better than mine. But it's the same idea, right? You want to build small and move fast. And especially if you're a small company, you have to do the same thing. And in order to do that, you have to use those pre-built functionalities. Once you start getting into the mid-size, well, now we've got a team that perhaps can spend more time on things. Maybe we're doing our own research, building some tools, building some features. And then you get into the large size where you might have an entire data team that's all about, we're just going to build and maintain a database for our 30, 40, 50, 80 data scientists. And we're going to enable them. And again, that's a whole nother scale. But really, we're going to focus on that small and medium-sized look at how might we implement some of these things. All right, so let's talk a little bit of how we approach this research. And this is not Xkcd. Cyanide and happiness is another good one that I like. I showed this to one of my developers earlier this week, actually, and he couldn't stop laughing. I told him, I sent it to him, and I was like, this is why I don't show you my code. But it's fine. I don't do a whole lot of code. Oh, great. It'll come back? All right. This seems to be the same problem that somebody had earlier today. For some reference, the next set of slides, really the rest of this presentation, really the whole presentation, I guess, is a compilation of about 5 years of me thinking and applying a lot of these principles. I started at my previous company, SPS Commerce, trying to lay the groundwork to build a research team. They didn't have one. And they were in the medium to large size of my reference. They had petabytes of data, but they didn't really have any motivation to do it. So it was kind of a bit of a slog. Luckily, at that point, Collaborator reached out and said, hey, we built a research team, but we need somebody who knows what to do with it. And I was like, oh, perfect. All right, I'll talk to you. And apparently, I was at least mildly acceptable because that's where I've been. But my first thought here is you need to be clear about your goals, right? What are you trying to accomplish? What are you trying to build? What are you trying to do? I briefly touched upon this earlier with that pyramid slide. But if you don't, then you might not actually build something that is important or that you care about. I'm going to illustrate this with a totally hypothetical and not true or based in real life whatsoever example. In fact, instead of using math or technology, we're going to talk about chickens because that's not something that's real. All right, so this is Johnny. Johnny has a chicken problem. He wants to get rid of those chickens. So he's got he already has a company. He's got maybe some machine learning engineers or data scientists. And he says, hey, get rid of the chickens. And he's got Diz who runs this team, or who he hired to run this team. And he says, okay, get rid of these chickens. That's your goal. So Diz comes back a little later and says, hey, Johnny, I've done it. We've come up with this super high-tech, fancy lasso rope thingy that's totally not an ML algorithm that can find these chickens. And then when it finds these chickens, it'll ship them off to Carl. Carl likes to talk to animals, so I'm sure it's fine. He'll love these chickens, right? Now Diz thinks this is all great. Problem solved, chickens removed, right? Get rid of the chickens. That was the goal. Is there like a better way to, like, should I wiggle a mouse the whole time? I don't know. Maybe I should. I think it might be sleeping. Anyways, chickens removed, problem solved. Diz is happy. Johnny, however, not happy. He says, he looks at Diz and he's like, I know you've only been working here a week, but this is not at all what I wanted. This isn't what I needed. I can't sell chicken meat if the chicken's all at Carl's place. Oh man. Well, what happened there? Turns out Johnny didn't want to get rid of the chickens in terms of getting rid of them. He wanted to get rid of them as like the mobster get rid of them, right? Kill those chickens, get that chicken meat, and we're going to send them to Carmen and sell those chickens and get some money. Well, crap. What happened here, right? We had a miscommunication. There are two parties here, both coming from their own perspective. Johnny's coming at this from the business side with his requirements and objectives. He doesn't understand what Diz does, right, from a technical perspective. He just knows, I need to get rid of these chickens. I need to do something with these chickens. Diz is coming at it with her perspective of what technical tools and capabilities. I got lassos. I know Carl over there. He's got a farm and he likes chickens. I don't know. Neither Johnny or Diz are to blame here, though. It's important. It's not a blame game. They both approach this problem from their own separate mindsets. Johnny came out and said, get rid of the chickens. Diz heard, move them somewhere else. Okay? There wasn't a clear-cut, well, why are we doing this? Diz didn't ask the question. Johnny didn't offer it, because we want to make money. We want to sell the chicken meat. So it's important to lay that out. What are we trying to do? What is our business objective here? Man, that is really fast. I'm just going to wiggle it the whole time, I think, now. All right. No, I lost my train of thought. Anyways, so what can you do here? Just communicate, right? Talk about the business objectives and write them down. And writing them down is going to be important because we're going to talk about how to stay on the right track later. Thought number 2, failure is good. Man. All right, I got too many things in my hands. All right, I'm just going to use the keyboard now. All right, so nowadays it's probably an easier thing to say that failure is good. It's certainly not always true. It's really important when you're talking research, when you're talking building things, especially with regards to machine learning and AI, go figure. These things don't always work. You might come at it and say, hey, I think the vodka in here is predictive of what Kyle's going to say over the next hour. Well, you might actually run the historical numbers and determine, hey, Kyle can actually hold his liquor really well, and there's not enough liquor in that bottle to make a difference. Probably not true, but that could be the outcome, right? And that would be a failure because you weren't able to predict on what you wanted to predict. But it may have been a failure in terms of the outcome, but you still probably learned something. You applied some technique, you collected some data, and that has value. I like to think of that this is a web of capabilities. So you start out with that single idea, or I forgot to wiggle it. You start out with that single idea or objective. This is like patting your head and rubbing your tummy at the same time, right? I got to wiggle the thing and talk and think. I don't know, maybe it's too many things. So you've got your first idea or objective. And let's just say you're successful at this, right? That's great. And now, maybe you have 2 new ideas, right? Maybe they came out of, we built this 1.0 version, and maybe now we've got a 2.0 version. But maybe also we collected some data, and that we had an idea to use. Like maybe instead of predicting, we can do some clustering on this data. So now we've got new ideas that we can test out new things. Maybe one of them doesn't work out, but you still might come up with that new knowledge tool or technique to do it. And you can keep going and say, all right, well, we had a completely unrelated idea that we just did, and that was successful, and those two merged and created a new idea. Now we're starting to build our web. And as it grows, you can start using even those failures. Maybe use that data again down the line. Or maybe you attack the same problem, but now you're 2 years older and wiser, maybe, hopefully, but at least more skilled. And maybe now it's feasible. Or maybe there's a framework that came out or an infrastructure that came out. There's constantly things, I mean, Google, Facebook, they're constantly open sourcing new tools that can be used that make things trivial compared to what happened in the past. That bird example that was on that first Xkcd slide, man, ImageNet that Google released made that problem trivial. Prior to ImageNet, it was virtually impossible and certainly impossible for small companies. But once ImageNet came out, well, now all I need is 50 examples of a bird and boom, I've got a model. That's incredible. And this works on the small scale too. If you come at it and say, well, maybe we know Python, we know scikit-learn, but down the road we try TensorFlow, maybe we try PyTorch, writing our own neural nets, and you come back to something that you did a year ago and you're like, oh, this is easy now. We can try it again. But the key is that failure wasn't a complete failure. You still learn stuff. And your web can continue to grow. I use this example all the time because we're consistently leveraging old things that we do. Whether or not it's that data or those tools and techniques, you always come back to and say, hey, we've got more and more and more ideas. And as you grow and expand, those ideas just continue to grow and expand. So I say Agile, not Agile. I like to, some proponents of Agile really focus on the whole ceremonies of Agile. Developers in the room are probably familiar with sort of over-ceremonializing. I like to think about it as the spirit of Agile, right? And these are kind of the things that I think about as it relates to machine learning. So you want to have a lot of ideas. You need to have a backlog of these ideas. And how do you do that? You talk to people. You talk to employees. You talk to people outside of your company. You talk to consultants. You talk to customers. But even more importantly is you listen to them, right? What are their problems, their concerns? What do they hate? What little things annoy them every day? Because those are the things that you can look at and say, hey, if it annoys them to have to think up different variations of how do you say the word lawyer, well, maybe we can make a tool so that they don't have to think of it, right? Can we just populate it for them? Get rid of that annoyance? So if you're listening to them, if you're listening to the problems that they care about, you can generate those ideas very, very easily. You need to constantly evaluate your current state. Always ask yourself, not just before, what are we doing or why are we doing it, but while you're doing it, should we continue doing it? You're learning as you're going through these projects. You're iterating on ideas, and hopefully you're still going down towards your business objective because you wrote it down, right? Maybe you're off on a tangent. Should you keep going down on that tangent? You started this for a reason. If you're no longer going towards that original reason, maybe you shouldn't keep going. Maybe you should reevaluate. I forgot to wiggle again. Man, this is harder than I thought it would be. And the last one, while it's waiting, is really fail fast. So this is, again, in line with the whole spirit of Agile. You want to move on quickly. You want to try things and go forward. If you're not, all right, that time I was wiggling it. Anyways, if you're not going towards your original business objective, you should kill it and move on, right? Don't go any further until you reevaluate. If you keep going down these tangents, which is really easy to do, by the way, with machine learning, it's like, oh, I tried this, now we want to go this way, and oh, we got some other data that's actually sort of related, but not really, and now we're over here. All of a sudden, you're way off course, right? And maybe that's the way you want to go, but pause. Make sure that's really where you want to go, because maybe there's less value over here than there is on the other side. Maybe you can go back over that way. And maybe it's, again, completely unrelated to the original path you were on, but more value. So consistently reevaluate. Go back to your prioritization system, more on that a little bit later, and determine where that new path might lie. There we go. All right. Don't always do ML. It sounds silly, but it is totally true. You know, when it's kind of like once you have a hammer, everything looks like a nail. This is totally true with machine learning. Once you know how to do it, you're like, oh, I can apply this everywhere. Literally everywhere. Don't. I'm serious. Think about it. There are sometimes really silly things that you can do that are way easier. Case in point, we had some time series data that we were working with that we knew was where we thought was predictive, right? Based on the time of day and day of the week, et cetera. So we built a lot of cool, fancy probability. We actually built this really fancy daily probability model. So depending on where you were in the day, you could see the probability of being there and where you might be in the future. Super, super fun stuff, super cool, presented really well. And then we started looking at the accuracy. Well, we were looking at the accuracy the whole time, but at the end we were looking at the accuracy of, okay, we have this system. It works pretty well. It does something. It's better than what we have today. Then someone thought, well, wait, what if we tried just using yesterday's averages? What would that look like? Turns out that was better than this fancy model that we had built. And it's not to say we didn't think about easier ideas ahead of it. We didn't think about this one in particular. But it's interesting how there are sometimes very, very simple things you can do that are not machine learning that will accomplish the business objective that you care about. So the point of this is not to be perfect and think of everything, because then you'll never get started. But it's to take at least some time to think about what are the ways we could solve this that are not machine learning or not artificial intelligence. Because those buzzwords are worth something. But you can still call it AI, as we talked about. All right, some practical discussion. So we talked a little bit about the idea stage and collecting ideas. Internal, external, but really you want to listen. Write them down and think about them. Throw them in your backlog. Just a list of random things you've heard, customers say, complaints, things you've seen maybe. Write it down. Then as you review that list, look for, all right, do we have data behind this? Is there data? Does it exist? If it exists, do we collect it? Is this data predictive? These are the questions you ask yourself because you're thinking about possible solutions. Are there ways that we think we can solve this based on what we've done before? Again, if you're looking at this from a small, medium-sized company, you don't necessarily want to say, we're going to accomplish the impossible, right? We're just going to do something that nobody has ever done before. It's probably not what you want to be doing. You probably want to be saying, hey, we are aware of a tool or technique out there that we think could apply to the data that we have to give us a business objective that we care about. Not brand new. So we're thinking about what are all the ways that we could solve this? And then you prioritize it. Well, how useful is this outcome if we're able to do it, right? Is it going to sell more? Is it going to make us more money? Is it going to provide a better customer experience? How hard is it? Again, this for developers in the room, you might think of, oh, the point system, right? Yay, God damn it. It doesn't really matter how you evaluate hardness, right? But the important thing is compare it to what you've done or what you know. It's going to evolve with you. As one of my lead devs used to say, the points don't matter and are made up anyways. And it's totally true. So you come up with a system, maybe it's t-shirt sizing, or maybe you use Agile points, that's fine. Whatever it is, as long as it allows you to think about this in terms of how similar is this to things that I've done before, and how long do I think it'll take? Because if you don't know that information, you can't weigh it against the outcome that you think you'll get, and you can't prioritize it. Ensuring your business objectives are understood, not just from the high level, right? If your boss comes and says, do X, and you're maybe a manager, make sure everybody knows what X is, right? If you're in the MVP discussion earlier, the strategy is important. Why are we doing this? Developers, machine learning engineers, data scientists, they make hundreds of decisions when they're optimizing models, building software, because you can't go to the product team for everything, right? What color should this button be? Maybe or maybe not important. They're going to make a choice. But if they know the goal is to provide some sort of night vision screen display, they're probably going to choose a red color, right? And not garish green. So if folks understand what are we going for, what are our business objectives, they can make the right decisions along the way. And kill those ideas when necessary. Is it a bad idea? There aren't really usually too many bad ideas. Is it illegal or impossible or would require Google to do, etc. Those are the kinds of things. But don't be afraid to just knock something out and say, we're not going to do this. Or maybe we'll do it later. There we go. Once you've decided we're going to do it, now you've moved into the R&D stage or the building stage, right? Review things often. If you've written down your business objectives, you can compare where are we at and what are we trying to do. Do we have a certain accuracy that we're currently at? Are we partway in defining whatever it is we're trying to define? Don't allow those scope creep, because now you've blown up your plan. If you say, hey, we started out predicting tomorrow's schedule, and you start figuring out, oh, well, we could predict the weather in 2 months. Okay, cool. But probably not related to what you're trying to do. And maybe it's useful, but you should go back to your prioritization and decide what's the value of that and what's the difficulty of that. So do we continue with what we're doing, add that as a new idea, or do we halt what we're doing and maybe then add it as a new idea? Or is this a new tangent that we go to? But either way, again, don't be afraid to kill these things, to stop where you're at and not move forward. And it's important to share your progress tools and techniques. If you've got a team, if you've got multiple people working on these, like I said, failure is good, but only if you learn from it. So if you have an ML engineer that says, hey, I found this really cool library out there that does X, Y, Z, hey, make sure everybody knows that you found this library that does X, Y, Z, because that's where you can build your web. If only one of your people knows how to use it, maybe you have 5 other people that don't. But if everyone knows how to use it, you've just multiplied your capabilities. And when you have a solution, you're still not done, right? You need to prove it works. Maybe you look at metrics. Maybe you look at one of the things that we like to do is, well, what is random? If you're trying to build a predictive coin flipper, well, can we beat 50-50? Right? That's pretty easy. Sometimes random is hard. Sometimes you can use what is normal. What do our customers currently do today? Is this better than that? Is there a cost to it that we can compare? You might have started this project not knowing what it'll cost you. But now at this point, you know, all right, well, if we run this, it's going to cost us 5 cents for every customer that runs it. They're going to run it 1,000 times a day, and they're going to give us $1 for it. That's probably not going to work out, right? But that's okay. Maybe you can figure out a way to make it cheaper. Maybe you shelve this until next year when GPUs are cheaper and more capable. Or maybe you shelve it and say, well, we'll come back when the technology is better, or when we have more data, when we can build a smaller model, things like that. Document, obviously write things down, because if you don't, you'll forget in a year what you did, guaranteed. And then again, at this stage, you can still kill things. All right, we built this really cool thing. It's not cheap enough, or maybe it doesn't scale, or maybe it doesn't quite do what we do, or maybe our customers can't understand how to use it. It's fine. Go ahead and kill it at that point and move on. There we go. All right, some final thoughts. A few miscellaneous things. Now, this is a topic that my team has literally spent days on. And the smaller you are, the more likely it is you're going to be caught building something that is biased. And that might be okay. You have to think about it. You have to be exceedingly careful about this. Because if not, maybe you have bad production results, or you have a potentially company-ending calamity if you build something that does something illegal. Bias is insidious. It can really sneak up on you. My favorite example, there's a team a few years back that was doing image recognition. It was fairly straightforward. They were trying to build a neural net that looked at the difference and classified the difference between huskies and wolves. Is anybody familiar with this? No? Oh, good. Oh, one person. You can't answer the question asked later. Neither can you, if you already know the answer. So we've got huskies and wolves, right? Now, the team had pretty good lab results. They said, hey, this is X accuracy, X percentage accuracy. They released it out into the wild, into production, and it failed miserably. And they started looking at it, and they're like, well, why? Why is this failing miserably? This is very clearly a wolf in this picture. And they did a bunch of digging, they did a bunch of research, they finally figured it out. Can anyone tell? I've actually represented the problem right in just these 6 pictures. I'm getting a bunch of nods. Yeah, who? Shout it out.
Snow.
Snow, that's right. They built their model based off of a flawed data set. All of the photos that they had of wolves were in their natural environment. Snow. Or, well, maybe it's not their natural environment, but all the pictures they have were of wolves in snow. So the neural net actually just ignored the animals completely. They did the analysis, and you can kind of look at these after images basically that says, hey, what pixels are important? And the animals were just completely unimportant. It only looked at the environment around them and said, hey, if there's snow, this is a wolf. And it's incredible because nobody really thought about that. And nobody probably would think about that. Like, it's really hard to look at all your data and say, hey, what else is in this data that might be problematic? Right? You're not going to think about, well, what's in the background of these photos necessarily. That's why I say bias is insidious. So you're never going to solve it completely, but you do need to think about it.
A related example, an image is trying to analyze tumors, right? And it turned out to be a font recognizer because it recognized the fonts used in the hospital imaging systems versus the fonts used in the testing systems.
I remember reading one about, I can't remember if it was certain doctors were better than others, and it learned to detect which doctor's signature was on there, and that was the predictive value because some doctors were better than others at identifying certain problems. It's insidious. You got to be real careful. But again, there's not a lot you can do about it other than know that it's going to happen and try and eliminate it where you can. Try and think about all the ways that it could go wrong and figure out, or rather answer these questions about how do we manage our risk here? Who's going to be hurt if we're wrong? Right? If we misclassify a wolf, if it's an academic research, no big problem. But if you built hey, take a picture of this to figure out if you're in danger or not, that's a little more risky, right? If it tells you it's a husky and it's actually a wolf and you're trying to figure out whether or not you want to pet it, outside of bad life decisions, that's a risky endeavor, right? Your problem who's going to be hurt there is definitely significantly worse than in academic research. I mean, we care about academics, but what's the cost of being wrong? Again, academic research, all right, maybe accuracy suffers. Business outcomes, all right, maybe we lose some money. If you're in the medical field, man, people can die. And I'm not saying you shouldn't do this, but again, look at what you're building, answer the question of what's the cost of being wrong and who's going to be hurt. And the last item is who's going to pay the price? Is your company going to pay the price? Well, then you might pay the price. You might lose your job. Is society going to pay the price? Anybody familiar with Tay from Twitter, Microsoft's chatbot? Yeah, that thing came racist real fast because it was learning from the conversations it was having, and people decided to teach it bad things. And we certainly lost, as I think society lost from that one. But what about non-users? Are non-users going to pay the price? If you build some sort of, is there a woodland fire detector and you miss something and a bunch of houses burn down, a bunch of random people that you don't know have to pay the price for that? That's a higher risk. So look at these questions and use them to define how you approach a problem. Man, I don't like this. All right, those are the 3 questions. But with bias, and this is separate, by the way, from legality. Legality is important, though. So now for an extensive discussion on legal issues. I am not a lawyer, and we're not going to be having an extensive discussion on legal issues. There's a lot of things we can mention here. But bottom line is you should have a lawyer if you're a business, and you should talk to them. And if you're building things, you should be aware of the laws that are out there. California has a bunch of laws. The EU obviously has a bunch of laws. There's this new AI law initiative in Europe that's coming out. I think Ohio has a biometrics law that's out as well. So just pay attention because there are things that are illegal as well as bad ideas. All right, I mentioned a couple of small business tools. So this on that scale of small, medium, large. If you are looking at actually implementing this, probably the most useful takeaway thing you could probably get There's a lot of tools out there that make machine learning really easy. Amazon SageMaker, Google's AutoML, I think it's still called AutoML. They allow you to just plug in some data and get output. If you want to do time series prediction on like, demand forecasting or whatever, oh man, just plug in the data and they'll dump it out for you. You don't have to do anything, it's amazing. Mechanical Turk, great. If you've got data that you need labeled, like I've got a bunch of pictures that I need to determine if they're clouds or wolves and I don't want to do the work, hey, go throw it on Mechanical Turk and they'll label it for you. It's great. And then if you want to build your own things, you've got scikit-learn if you're very, very, very basic. If you're moving into the moderately advanced, there's tools like FastAI that are designed to be easier things to use than building your own neural nets. It's one of my favorites. But this is obviously completely outside. If you're a machine learning engineer or data scientist, you should probably just ignore this because you probably know way more and you'll probably implement way more. But if you're a 1 to 2 person shop, again, using those pre-built tools and functionalities and libraries is important if you want to move quickly. One last plug. If you're a data engineer, come talk to me. And I've got my LinkedIn on the left-hand side if you want to chat about this stuff. Obviously, I do this for my real job. I love talking about it. I love doing it. And on the right-hand side, if you want to copy these slides, there's a QR code and the bit.ly link. Any questions? No questions. All right. Let's see. All right. Well, thanks, everyone.